Hello everyone, I'm Alex Rojas and welcome back to my YouTube channel. Today it will be about geomagnetic reversal. So I will be saying a little bit about what is geomagnetic reversal, how scientists found out that this was happening on Earth and how frequently it was happening. And finally I'll be discussing a little bit of the hypothesis of what will be the effect on human beings if something like this will happen again. So I'll need to start talking a little bit about the magnetic field on Earth. So there is no secret, if you grab a magnetized needle and you suspend it somehow so it is free to rotate, the magnetized needle will align itself with the geographical north and south pole of Earth. So actually by tradition you label whatever side of the magnet is aligned with the north pole of Earth. You assign this as the north magnetic pole of this magnet, and the opposite, the south pole would be the other one attracted to the south pole of Earth. This by itself, this is how traditionally it was done, but this by itself brings a very counterintuitive fact, that is that the geographical north pole is attracting the north pole of the magnet, but we know that only opposite poles attract to each other. Therefore, the geographical north pole of Earth is actually the magnetic south pole of Earth, of this huge magnet. And the geographical south pole of Earth is actually the magnetic north pole of the Earth. And so the fact that the needle aligns itself north-south, it somehow shows that Earth itself is a huge magnet. And the fact that we make the decision to label the magnet this way, it actually makes the south pole the geographical north pole and the magnetic north pole the geographical south pole. Anyways, but what is geomagnetic reversal then? Well, this is an effect that every several hundred or million years, this needle or this magnet will actually flip. So you will be having something like, if you grab your current compass and you do some time traveling and you go back, let's say 41,000 years ago, that was the last one that it happened on Earth, your compass will be actually giving you the very wrong orientation. You won't be able to navigate with this compass, and this flipped of the magnetic field. So the whole magnet itself. So in this case, you will have here the magnetic north poles and the magnetic south pole. So actually flipped, and it lasts only 400 years. And so the idea is to well, this is what geomagnetic reversal is. It's just a change in this huge magnet of Earth is just flipping back and forth. So now, how scientists knew this when this happened, and for how long it happened? So what was the technique, or what is the technique or some of the techniques that they use? Well, one of the methods used is, if you go to the middle of the Atlantic Ocean, you will find something that is called the MidAtlantic Ridge. And if you actually look closer, you will see that that ridge is actually cracked in the middle. There's a gap right there, and it's running all around Earth from north to south, and it actually goes up back again. And so what is this? What's going on here? And how this will help us to actually map this flipping of the magnetic field of Earth? Well, what is happening is the following. Let's assume you have the crust here of the ocean, or the bottom of the ocean. And what is happening is that below that you have this sea of volcanic lava, and this lava is actually pushing this crust apart. So there is forces from this crack here. There are forces going to the opposite directions, and this is one explanation of what are the forces driving. If you look at this profile of South America and this profile of Western Africa, you will see that they fit pretty nicely, like a huge two pieces of a huge puzzle. Well, these two massive portions of land are moving away from each other at a rate similar to the rate of how your hand or fingernails are growing. So it's about what, a millimeter per week or something like that. So that's how fast these two things are going apart, and the force driving that is the volcanic lava coming from the middle of the Atlantic Ridge. So what happened is that if you're creating a gap to push these two massive parts of continents apart from each other, you have to fill out the gap somehow. And the way you fill it is that every time you have lava pushing out this, and this is moving away from the middle, that lava actually starts to occupy that empty space. And the more you push, the more lava has to substitute whatever your land is moving away. Now, if let's assume you're here at the bottom of the ocean, and you're carrying a compass right here. If you're walking away from this middle gap, the further you walk, the older the rocks will get, because these are very fresh and brand new rocks that just came from the volcanic lava. They have no memory because this is like a liquid. But as soon as they come here and they become a solid, they stop being from liquid and now they are solid, they will freeze up and they will somehow register whatever conditions, especially in this case magnetic conditions, the Earth has at that specific moment when they solidifies. So, for example, right here you will have rocks of 1 million years old. Here you will have rocks of 100,000 years old. Here you will have 10,000 years old, and right here is the brand new rocks. And if you walk with a compass, you will notice that the compass, the further you go, it will start to flip back and forth, back and forth, back and forth. So you will be able to map by knowing the age of those rocks and knowing what is the magnetic field register on those rocks. You will be able to map how the magnetic field of Earth was switching back and forth back in those days. And there is, for example, if you walk 41,000, the equivalent of 41,000, sorry, this is not K here, 41,000 years, if you grab a sample of this age, you will immediately see that the compass for that rock is actually pointing the opposite of your current compass. And now, how these rocks remember the magnetic field of Earth? Well, what happened is the volcanic lava contains iron, and iron is a ferromagnetic element that somehow they align with the magnetic field. So when they are liquid, imagine that you have this liquid with an incredible amount of magnetized needle, tiny magnetized needle all over it. Well, what happened is that if it is a liquid and you have a huge magnet nearby, in this case is Earth, all of them will align themselves with that magnetic field, that external magnetic field, and in this case is the Earth magnetic field. And once they are aligned and they become a solid, they become a rock, they will maintain this alignment forever, even though the magnetic field of Earth switch back to normal, let's say. Well, they won't be able to switch back because they are already a solid, so they are not free to move anymore. They are frozen at that location. So this is one way how scientists discovered this, or actually were able to map these different geomagnetic reversals. Now, what will be the effect on human beings? Oops, that's the wrong. If this happen, well, the effect will be. This is still a speculation. There's no certainty, but remember, this is the south magnetic pole, and this is the north magnetic pole. Let me call it magnetic, so to distinguish that this is not the north and south geographical poles. So you have some magnetic lines. In this case, they are going in, and here you're coming some magnetic lines coming out, right? So you have some magnetic field lines going around, and the way it works basically is that if you have cosmic rays or solar winds or some ions, the ions get trapped by the magnetic field due to Lorentz forces. So that means that if you expose a charged particle to a magnetic field, the magnetic field will act on the particle and will change the direction of that particle. So this is somehow like a force field that is protecting Earth from all the radioactivity or the radiation from I don't know, intergalactic radiation or cosmic radiation. Well, when you flip the magnetic field, sometimes it's not necessarily flipped completely. It goes to a period where it shut off, so there is no like a very weak magnetic field, so the compass won't point anywhere. It's sort of like a random location, so there is no, so the liquid lava when it gets frozen, it still is not showing any peripheral magnetic orientation. That means that at that moment Earth just stopped from having a magnetic field. So if that happens, then you won't have this sort of shield that is actually protecting you. So you won't be having all this thing, and then your cosmic rays, and ions will be just going directly to Earth, and it will be somehow being affect all living beings inside the planet. And this is actually being proven. This hypothesis, there is strong evidence. They went to Iceland and they grabbed an ice sample. So they have an ice sample that contains some air bubbles trapped in, and they check, and these air bubbles contain an element that is beryllium 9 and beryllium 10, and this element will be produced if under these circumstances. So there is a proof, or there is a link, that yes, at 41,000 years ago, or ice samples from 41,000 years ago contains a higher density of these type of elements, which means that the Earth was exposed to solar winds or cosmic backgrounds radiation. And this will affect, definitely, this will affect life on Earth. Another hypothesis is that if you have a switching magnetic field, during that transition, what you will be having is a very volcanic activity. So the volcanoes will be very active, will become very active on Earth. And the problem with volcanoes is that will expel silicon dioxide. Now, silicon, if you look at the periodic table, you have carbon, and right underneath carbon you have silicon. And therefore, if they are on the same column, they have very similar chemical properties. Well, silicon dioxide is kind of a cousin, or is related to chemically to carbon dioxide. So when you have all these ashes coming from volcanoes, and they are rich in silicon dioxide, you will breathe those ashes, and then it will come, because of the similarities with carbon dioxide, it will somehow be, the body won't be able to tell the difference, so it will grab these things. But the problem is that the body knows how to get rid of carbon dioxide. First of all, it's a gas, this is a solid, And then for our lungs and hemoglobins, they are not exactly trained to get rid of silicon dioxide, and they will somehow poison us. And so that's another concern. If this flipped happen, you will have, if by doing that you have a higher volcanic activity, you will have a very highly polluted earth to breathe for all of us. Anyways, this is very interesting how several things linked to so many, and just a simple fact. Actually, the reason why many scientists went to grab a rock from the middle of the ocean here is because they were trying to find like the purest and oldest rock, and they found that they are the youngest one. And this is also connected to plate tectonics and several other subjects. So I hope you like the video. Just let me know if you have any comments or questions. And well, thank you. Bye.